Yeah.
It's crazy.
Any questions that stood out to you that you'd like us to go over?
There was one, I think it was like example 9 or 8, where it was like the use of cotangents, where it was like, but then after I re-looked at it, I was fine, but.
So number 8 is where you have
No,
the
no.
multiple angle tangent of x over 2. Number 9 is where we had to use, was number 9? No, number 9 was where we used factoring to simplify that.
Oh, I don't know which example then it was. What? Every time.
Hey, Sydney.
Hi.
Did you have a chance to look through the video or at least part of it?
I looked up for 2.3.
Yes.
I looked up part of it, but I didn't get to like fully go through it all.
Yeah, that's what we were just talking about. It's such a long video that I didn't think you guys would be able to see all of it. But even if you saw part of it, then at least you have a little bit of idea what we're going to be doing today. Ezra, did you find which one you were talking about?
He just left to go get his worksheet because he left it in the other room.
Oh, okay, no problem.
Yeah. He ran inside.
Okay.
I thought
Jose.
it would be easier.
Hello.
Sydney, what were you saying?
I thought this online thing was gonna be easier.
Oh, I don't know. I mean, I think it's just where, I don't know how other class, with our class, you know, since I am posting these video lectures, it does add a little bit of extra time for what you need to be doing. Because you're watching the video and then coming to class. But my big concern is, you know, during class time, like yesterday we had some trouble in one of my classes where one of the students had lagging in their video and audio, so they were not able to see me and hear me, you know, very well. And so that's what I was kind of concerned about, is if we did live lectures and any of us lost internet connection or something, then, you know, that kind of takes away from our lecture. So even during like today, you lose internet or your internet slows down, you still at least have the video lecture that you can go and look at. So even if you don't catch anything from today's class, you still have the actual lecture to look through.
Okay.
Yeah, so I know it does add a little bit of extra time to what you are already doing. And you know, anytime it seems like you are spending way too much time, what I would say is break it up into pieces, you know, so because like I said, the video I just posted for 2.3 last night is a little over 2 hours long. So I would say probably break it up into pieces, just make a note of, you know, at what time you stop, so that way when you pick up, you can start right from there.
Right.
Yeah. I like had to break it up. I like had, so I play all my videos on like 1.5 times speed.
Oh, okay.
I have like short attention span, so I'm just like, okay, we gotta go. So then like after like an hour and a half, I was just like, okay, I need to do something else real fast. And I like got up and like did my morning routine of like brushing my teeth and like putting lotion on my hands and just like doing something else for like, I don't know, 10 or 15 minutes, and just like this, yeah.
Yeah, and you know, obviously, I think that's a great strategy because especially for videos this long, and you know, kind of looking at pretty much the same thing can also get very tiring. So it's definitely a good idea to break it up, kind of like what I think Ezra, you were talking about earlier, was you thought you would see the video for an hour and do homework for an hour. And so I would still suggest that's a great strategy. Just whatever video you have seen so far, I would say go ahead and try working on some of the homework assignments, and then maybe come back and finish the other half and then work on the remaining part.
Yeah.
Okay. Jose, did you get a chance to look through the video or at least part of it?
Yeah, on the packet, I got all the way to example 4.
All the way to example 4. Okay, that's really good. And anything you wanted us to go over today? Any questions that you had?
Um, no, honestly, I've been good up to that point. It's just more about the whole time. Since
Okay.
like I have a class right before this, English,
Okay.
so I usually start the videos right after, but it's kind
Okay.
of hard to fit the 2 hour video.
Yeah.
Yeah. And that's what I was kind of talking to Ezra and Adrian about this earlier was by the time I got done recording, I was like, I thought maybe it would be like hour and a half video, but by the time the video got done, and it actually took hour and a half just for my program to render the video so that I could even watch it. And so this was like a 3.5 hour process by the time everything was said and done. And then I noticed it's a 2 hour plus video, and I was like, you know what, I will not even worry about it if you guys did not even see like 3/4 of the video, as long as you even just looked at a portion of the video, so at least you have an idea of what we're working on today. I'll be happy with that. So Ezra, did you find the problem you were talking about?
I did not.
You did
I had
not?
to run. I had to run real fast because I had a breakfast burrito inside the toaster oven and I forgot about it. I thought you went to go get your packet. No. Let me look through it real fast.
Okay. That's a good story, I like it. Yeah, I was hoping that Adrian Medina would kind of come in by this point, but maybe he's getting delayed for some reason. So after Ezra finds his problem, we'll go ahead and take a look at a couple examples here.
Is it using trigger identities to substitute with or no? Gosh, I can't find it. Is it down here? I don't know. It was like something with tangent where it was like x minus 1 and then tangent of x minus 2, and then you did or not that way. It was x minus 3 and x something else. Oh, the one with 3.
I think you might be talking about number 9.
Oh, I think no, that one. That was an example 5. That was like the one with the 3. No, because it had maybe it's 9.
The tangent, either 9 or 5.
Well, not 9 because that one was and then I just showed him 5 and he said it wasn't that one either.
Not 5 either, okay.
What the hell? Oh, is it number 8? Perhaps? Or with like the 3 and like tangents and the -1? Were you using it was the use of the cotangent. I don't know. Tangent and cotangent is what was inside of it.
Tangent and cotangent. Okay, I'm actually gonna have to find it.
Number 6. No, no, that's the sign. Well, why don't you just circle them when you come across them? Maybe I should remember the timestamp inside the video. Do something. Okay.
I am not seeing anywhere where we used cotangent. Now we have arctangent, tangent inverse.
Oh, it was arctangent, I think, yeah.
Okay, so arctangent happens in number 9 because that's how you actually come up with your solutions for number 9. Which would have to be towards the part of the video.
Maybe in the example number 9, because, yeah, this part. Were you confused about like? Was it just the use of like the substitution? Yeah, I think that's what it was.
Yeah, because even in example number 9, if you look through that, especially where you are, this is on page 10 of your handout. So once you get your tangent of x minus 3 equal to 0, and then tangent of x plus 1 equal to 0, to be able to solve those, to get x by itself, we need to use the idea of the tangent inverse function. And so yeah, that is where we introduce the arctangent. And then here, we had to keep in mind that the range of the arctangent function is between pi halves and pi halves. So that means whatever x values you are looking at, the answer that comes out to be would have to stay between those interval. So that's kind of, I don't know if that was the part that was throwing you off.
I think the only part that's throwing me off is when it was giving the solutions to it, where it's x arctangent of 3, because I'm a little confused on what that is, because does that fall outside of our range of negative pi halves or no?
No, it's going to stay within, because, you know, if you're talking about going from pi halves or negative pi halves to pi halves, remember that is pi halves is 90 degrees, you know, if you're going in the counterclockwise direction, and that's going to be basically negative 90 degrees if you go clockwise, which also happens to be the 270 degrees if you were looking at your unit circle.
Mm-hmm.
So basically, you're just looking at quadrant 1 and
so
quadrant 4. So as long as your angles stay between 90 degrees to negative 90 degrees, your answers will be okay. So if you actually take arctangent of 3 or tangent inverse of 3 and put that in your calculator in the degree mode, it actually comes out to be 71.6 degrees approximately. So you know it's basically between 0 and 90 degrees, which means it's falling within that range of negative pi halves to positive pi halves.
Okay.
And when you look at arc tangent of negative 1, that basically comes out to be negative pi over 4, or basically negative 45 degrees. So again, you know, negative 45 degrees is going to be between 0 and negative 90. So again, it's going to be within the range of your inverse tangent function. So both angles are different. And you know, if it's too confusing, you can just leave them as x equals arctangent of 3 and x equals of arctangent of negative 1. And like I said, just plug them in your calculator and make sure the angles in degree mode are going to be anywhere between negative 90 to positive 90 degrees.
Okay.
Okay? All right, so I'm not sure if Adrian's going to be here today or not. So let's go ahead and take a look at a couple examples here, guys. So, and it would actually help if you guys have your printout that I gave you for the unit circle, because it makes a lot of these calculations go fast and you don't have to kind of think about which angle am I going to get these values at.
Mm-hmm.
Oh, and the other thing I wanted to talk about was, did you guys get a chance to check your ames.edu email boxes? Not the D2L email, but the other one through Google.
I have not.
Okay.
Oh wait, was that the test that you sent back to us?
Yes.
Yeah, I did. I got
Yeah,
to
I
see
saw
it.
it too.
Okay. Adrian, did you get to see yours?
Yeah, I got it.
Okay. So Sydney, you're the only one who hasn't checked it?
Yeah.
Okay. All right. So if you guys will remind me maybe here in about half an hour, let's do some examples from 2.3, and then I would actually just like to discuss your test with you before we dismiss today's class. Okay, so let me pull up our homework here. So we're looking at section 2.3, and I think the first example I wanted us to look at is this one here, number 13. This is going to be very similar to the first example that we had in our handouts. So let me just go ahead and write this down.
Could you screen share it with us?
Oh, did I not? Sorry.
No, not yet.
Okay. There we go. Okay.
Hey.
So number 13 over here. Okay, so this is cosine of x plus 1 equals negative cosine of x. Okay, so remember the idea here is you want to get your cosine function on the same side. So we'll go ahead and of course take this one from the right hand side and add that to the left hand side. So we'll cancel it out on the right hand side. Cosine plus cosine will give you 2 cosine of x plus 1. And then of course 0 on the other side. Now the idea is we want to isolate our cosine of x function, which means we'll start by subtracting 1 first. That will give you negative 1 on the other side, and then divide by 2. This is where that unit circle idea comes in. Now you have to find, now remember, cosine has a period of 2 pi. So the first thing we do is start inside the interval, which will go from 0 to 2 pi. And in this interval, for what angles will our cosine function be negative 1/2?
2 pi over 3, and then 4 pi over 3.
Yeah, because these are going to be in quadrants 2 and 3, right? This is where our cosine function is negative. So you said 2 pi over 3, and what was that other one?
4 pi over 3.
Yeah, very good. So your x values are going to be 2 pi over 3, 4 pi over 3. Did the rest of you find those angles where cosine is negative 1/2?
Yeah.
Yeah?
Yeah.
Okay, and then remember in the general form, because since they did not ask us to solve this for that interval, they just said solve the equation. So in the general form, you are going to take these same angles, and does anybody remember what we add next to it?
The interval, like the, yeah.
2 and pi.
Very
2 pi.
good, yeah. Because you have to know that basically those are the coterminal angles. If you keep going in circles with that 2 pi, you are going to get infinite options here. So to both of these angles, we'll add 2 and pi. And that 2 pi, of course, is coming from the period of our cosine function. And then again, n can be an integer value. Any question on this one?
I think that these are kind of easy in a sense that it's like you're looking for x, you're solving for like x if you just replace it by the sign, and then you go into depth on what that x means.
Okay.
Is the way I'm thinking about it.
Okay. So you think you're okay with these type of examples then?
Yeah.
Okay. So the next example that I had us working on is, let me see. It was actually number 22 here.
Secant squared.
That's secant squared of x minus 1 equal to 0. So any ideas on where you would start with this guy?
Would you start by by adding the 1 to the other side?
Yeah, very good. Add the 1 to the other side.
And then you would square root the secant squared and the 1, and then making sure that you did positive and negative.
Very nice, yes, because you want to get rid of that square on the secant function. So we'll take a square root on both sides, and the square root always gives us a positive and a negative answer. So you're left with, oops, secant. I'm not sure what's going on here. Which will just become plus or minus 1. Now again, when we are talking about the secant function, you can again go back and use your unit circle. So how would we go about doing this? What information can you use from here? Think about your trigonometric identity. What can we use here for the secant function?
Cosine. Number one.
So secant is the reciprocal function for which one?
Cosine. Yeah.
Cosine. Yeah, so you want to use the idea that secant of x is 1 over cosine of x. So if basically secant is positive 1 or negative 1, what will your cosine function be?
0 and pi.
Say that one more time, Jose.
Would it be at 0 and pi?
Yeah, because basically if you just interchange the positions of cosine and the positive or negative 1, you basically end up getting where the cosine function is also positive or negative 1. And yeah, that happens at 0 and at pi. So in the interval from 0 to 2 pi, you would again be looking at x equals 0 and x equals pi. And then in the general form, what will they end up becoming?
X equals 2 and pi, and x equals pi plus 2 and pi.
Alrighty. Does anybody see how we can clean up these two answers?
Isn't it something like m pi and I don't know. You can clean it up though.
Yeah, you're actually right. It will become x equals n pi, because think about it. If n was the number 0, we would end up with 0 times pi, which is 0, which would give us this angle here. If n was 1, you'd get 1 times pi, which would give you this angle here. And then same thing if your n using this statement here, if n is 1, you get your 2 pi. So you would actually keep going through this difference of this pi. So 0 pi, 2 pi, 3 pi. And then on the negative side, you would actually go negative pi, negative 2 pi, negative 3 pi. So you can actually combine both of these general form into just this one answer here. So this guy will be your solution for number 22. Does that make sense? Do any of you have a question on that?
It makes sense.
Okay. What about the rest of you, Sydney?
It makes sense to me
Okay.
for now.
For now? Okay. She's like, I don't know what's going to happen later. All right, guys. For our next example, I wanted us to look at number 23. Okay, so what do you think we need to do here first? Let me go ahead and get this done.
Subtract the tangent x.
Very good. Alrighty, so first by subtracting the tangent of x. So you've now got 3 times tangent cube of x minus tangent of x equals 0. Okay, and then what do we do?
You take out a tangent x.
Yeah, very nice. Exactly. Factor out, since both of them will have one tangent of x in common, we factor this guy out, and what are we left behind with?
Tangent x times, in parentheses, 3 tangent squared x minus 1.
All right, 3 tangent Square root of x minus 1 as your placeholder. Very good, equals 0. Okay, and then what do we do?
You set them both to 0.
Yeah, very good. So take each one of them and set them equal to 0. And then, of course, you're trying to get for this right-hand side, the 3 times tangent squared of x minus 1. You want to isolate the tangent itself. And then for the left-hand side, tangent x of 0, we can basically use the unit circle to come up with what values of x can we have here. But let's go ahead and clean up this right-hand side first. So you start by moving that 1 to the other side, kind of like what we did in the previous example. And then, of course, we divide everything by 3.
Mhm.
And then what do we do next from here?
Square
And
root.
then we square root both sides.
Very good.
And then you rationalize.
Yeah, very good. Rationalize, because you end up with square root of 1 on the top, which is just 1, square root of 3 on the bottom.
Oh, I didn't.
So square root of 3 over 3. Now what will we have for this? So let's do the first part here. For tangent of x equals 0, what angle are we looking at for x? Because remember, tangent is sine over cosine, right?
Is it just 0 and pi?
It's going to be, yeah, it's going to be at 0 and pi. And remember, tangent has only a period of pi, so you're looking at the interval which goes from 0 to pi. So your x will be 0, x will be pi. So this is actually, I'm going to go back to our previous example. So you had the same angles here, 0 and pi for this. So remember how in general form this came out to be x equals n pi?
Yeah.
So the same thing that's going to happen here in the general form. This part will also become, sorry, that should be x. This will become x equals n pi for tangent of x equals 0. And then what do you think is going to happen for this one here? What should our x value be from here? And again, you can start by looking in the interval from 0 to pi.
Is it going to be pi over 6 and 5 pi over 6?
You said pi over 6 and 5 pi over 6 because you are doing 1/2 divided by square root of 3 over 2, which will give you 1 over square root of 3. And yeah, I think those are the correct answers because both of them are giving you either positive or negative square root of 3 over 3. All right, very good. So that's x equals pi over 6 and x equals 5 pi over 6. And then in general form, what will they be? What do we add for a tangent function?
Is it just n pi? Yeah.
Yeah, because the period of tangent is just pi, so you're adding n pi to both of these angles. Basically, those are our 3 answers here. You've got x equals n pi, which came from this first part of our answer, and then x equals pi over 6 plus n pi, and then x equals 5 pi over 6 plus n pi. All right, very good. Did any of you have questions on this one?
Nope.
No.
No? Okay. All right, I think the next example I had for us was number 28 over here. Wrong one. Okay, any ideas, guys, where we should go with this one?
Subtract 2 from both sides.
Okay, subtract 2 on both sides. Okay, so you'll end up with cosecant squared of x plus cosecant of x minus 2 equals 0. All right, very good. And then?
You can factor.
Oh, okay.
You could like use substitution and replace cosecant squared. Cosecant x with like x and then just factor.
Okay, so just imagine that, guys, an x. So you have x squared plus x minus 2. So what will this factor into?
Positive 2 and negative 1, or like x plus 2 and negative 1.
Okay, yeah, because when we multiply positive 2, negative 1 gives us negative 2. And when we add positive 2 and minus 1 give us plus 1, which was our center term or our middle term. So how does that translate into the actual problem now? How will you write this down?
Cosecant plus 2 in parentheses and then x, or cosecant of x minus 1. Or,
Yeah, very good. Jose, Sydney, and Adrian, were you guys okay with this part?
Oh,
yeah.
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 No questions?
No.
Okay. All right. And then, of course, what do we do from here?
Set them both equal to 0 and then just solve, yeah.
Yeah, solve for this cosecant. And so this guy will come out to be, let's see, subtract the 2 here, add the 1 here. So negative 2 or cosecant of x equals 1. And then kind of like you did with the secant function, cosecant would be the reciprocal for which one?
Sine.
Very good. Cosecant of x is the reciprocal of sine. So what would be the sine value here if cosecant is negative 2?
Does it fall out of the range?
For cosecant function, does it fall out of the range? No, because cosecant is going to be where, those arms go up, right? Where the sine has a hill, cosecant will have a valley. Because think about it, if your cosecant is negative 2, this is going to become 1 over negative 2, right? Or basically negative 1/2 for the sine
Is
function.
it? Oh yeah. Is it gonna be pi 6th?
I believe.
And pi 6th?
So this is negative, right?
Oh yeah. So it's gonna be actually 7 pi 6th.
7 pi over 6. And what else?
And 11 pi over 6.
Yeah, because you're going to have 2 answers since sine can be negative in 2 different quadrants, I guess. So for this guy, and again, remember you're going in the interval from 0 to 2 pi. So you're looking at quadrant 3. where sine is -1/2, so that's 7 pi over 6. And quadrant 4 was 11 pi over 6. Oops, missed my 11. Now, what about this guy here, which will come out to be basically sine of x would be 1 over 1, right?
Mm-hmm.
Sine of x is just 1, and where are we looking for that one?
Would that just be pi halves?
Would
Or
just be
yeah,
pi
pi
half.
halves.
Yeah. So same interval. All right, so just go ahead and tell me what our general form looks like for these guys.
7 pi 6 plus 2m pi.
Very good, yeah. So for each of these angles, you are adding 2n pi to them.
Cool.
The 3 angles, and all 3 of them will get the 2n plus pi. Okay, any questions on this one? Were you guys okay? Did I lose any of you?
No, I'm still good.
You're still good?
Yeah, I'm
Yeah,
good.
still good.
Okay, okay, very good. Good job, guys. All right, how about, I'll give you guys a couple minutes to work through number 31, and then let's see what you come up with.
2.
This would be similar to example 5 in your handout.
Which one did you say to do?
31.
Okay.
See, I wasn't so sure though if you need to multiply it by negative 1. Oh, I need to just... Oh, wait, I did that.
So where did you guys start with this one?
I started by separating the 2 and the sine squared of x by putting the sine squared of x in parenthesis. And then I used the trig functions, that way it would be 1 minus cosine squared. So that way.
Oh, okay. So you're replacing this guy with the trig identity.
Mm-hmm.
So what did you use here?
1 minus cosine squared.
Very good. Were the rest of you able to do that, or did you use something different?
I did the same thing.
Did the same thing? Okay, and then what do we do after we make that substitution with the trig identity?
Distribute the 2.
Okay. So distribute the 2. 2 minus 2 cosine squared of x equals 2 plus cosine of x, okay?
And then I set it equal to 0, so I subtracted 2 and subtracted cosine of x.
Oops, sorry, okay. So which 2 did you subtract, or does it really matter?
It doesn't really matter because they're going to cancel anyway.
Exactly, very good. So subtracting the 2 will cancel them out. And then which cosine did you move?
I moved the cosine on the right to the left, so that way it would be negative cosine on the other side. And then is that where you're able to multiply by negative 1?
You can, because I think it would make it easier. And I'm actually writing with my hand because my pen stopped working. So that's why it's looking like super sloppy in what I'm typing. I don't know why my pen stopped working and it will not come back online. So I apologize for that. Okay, so
It
you
looks fine.
move both your cosine to the left-hand side, basically.
Yeah.
And then you said you multiplied everything by negative 1?
Yeah.
Okay, so if we basically multiply the entire equation by negative 1, basically your negatives will become positives, right?
Yeah.
Okay, so we end up getting 2 cosine squared of x plus cosine of x equals 0. Okay, and then what do we do?
And then I pulled out a cosine since it's a common term. So that's cosine of x parenthesis 2 cosines plus 1.
Very nice. So kind of like what we had done with that tangent example earlier. So you're left with 2 cosine of x plus 1 equals 0. And then what do we do?
And then I just separated them, so it was cosine equals 0 and 2 cosine plus 1 equals 0.
Alrighty, very good. And when you simplify the right-hand side, what do we end up getting?
Negative, or the right-hand side or the right-hand side? Negative 1/2.
All right, very good. Yeah, so at this point, then you're basically just finding at what angles is cosine going to be 0 and going to be negative 1. So what will those x values be?
Cosine negative 1/2.
Pi over 2, 2 pi over 3,
Sydney, can you speak just a little bit louder? I'm not able to hear you clearly.
Pi over 2, 2 pi over 3, and 4 pi over 3.
Okay, so you gave me pi over 2. And did you say 3 pi over 2?
No, 2 pi over 3.
2
Oh,
pi. Oh, okay, I see what you're
oh
saying.
yeah,
Okay,
I'm going on to the next one, my bad.
that's okay. So
And then-
you're going basically in order. So you've got for angle 0, you have pi over 2. For the negative 1/2, you have 2 pi over 3. And then what was the next one?
4 pi over 3 for negative 1/2 as well.
Okay, 4 pi over 3. And then you had one more, right?
No,
You sure?
hold up.
Yeah, 3 pi halves.
Yeah.
There we go. 3 pi halves. And I think that will be it, right? 4 angles.
Yeah.
And then this one, let me just verify. What problem was this? 31. So for 31, our instructions were that they wanted specific answers that would stay in this interval from 0 to 2 pi. So since they're asking us to find the solutions in the
So we
interval
don't need to
from
do
0 to 2 pi, we don't have to do the general form here.
Yeah,
So this will be,
your answers.
alrighty. I really wish my pen would come back online because this is like the sloppiest writing I have ever written. But I'm sorry, guys. I don't know why it stopped working on me.
Maybe it's battery died. Oh yeah,
Sorry?
maybe it's battery. Maybe it's battery died.
So when I go under settings, it shows I have 92% battery. So I'm not sure
That's
if
weird.
the settings is not working or I don't know what happened, but I will troubleshoot after class. I don't want to use up your class time for that. So the next example I actually wanted to look at is this one here, number 37. And this one, let me make sure, is actually going to be like example 6. And remember example 6 was where we had to check for extraneous solutions. So it's going to be one of those examples.
It's not squared, is it? I think so. So we have to square. Oh, okay.
Okay, so what did you guys figure out?
It's one of the ones where you have to square root, or you have to square both sides.
You have to square both sides, yeah? So we're going to take our cosecant of x plus cotangent of x, oops, and square that, and of course 1 squared on the right-hand side.
Is one.
And then when, of course, you'll need to FOIL the left-hand side. So let me know once you have that answer.
Is it cosecant squared or x squared plus 2 cotangent cosecant x squared plus cotangent x squared?
Okay, so you said cosecant squared for the first part. Okay, and then what was next?
Plus 2 cotangent cosecant
Okay.
plus cotangent squared x.
Alrighty, yeah, very good. Nicely done. So cosecant squared x, then in the middle would be 2 times cotangent x, cosecant x, and then of course cotangent squared. Now, what do you think we should do next? Because we have to either make all of them into cosecant, or we need to make all the functions into cotangent.
I think we should.
I'm not sure if we will be able to get that. We may still have some more simplification to do.
Yeah.
But what do we want to do? Do we want to convert this into cosecant or cotangent?
I think we should try to convert it into cosecant.
Cosecant? Okay, and then what identity would we need to bring in?
The Pythagorean identity.
Okay, so if we're keeping cosecant, so this guy will stay the same. Right now, we won't be able to do anything in the middle. So we'll keep those guys the same. So which means you are rewriting him, and what will that become?
Cosecant.
Squared x minus 1.
Yeah, cosecant squared x minus 1. Yeah.
Yes, because it's those two. So cosecant squared x minus 1, and then we have 1 on the other side. All right, where do we go next from here?
Could we combine our like terms and bring that 1 over and setting it equal to 0?
All righty, so let's see. We are subtracting this one. These are gone, and which would be your like terms here?
The 2 cosecants, or the 2 cosecant
Squares. All righty. All right, so let's see if we clean this up. This will give us 2 cosecant squared of x plus 2 are cotangent x cosecant x, and this guy becomes minus 2 here, 0 on the other side. All right, very good. And what do you think we can do to simplify this?
Could we pull out cosecants? Ooh, no.
No, because to me,
Oh, we can pull out 2 though.
we can pull out a 2. Yeah, we can do that. All right, let me move this guy a little bit up. So we bring the 2 outside, which will leave us behind with cosecant squared of x plus cotangent x cosecant x minus 1.
Mm-hmm.
All right, and then what do we do? Couldn't we divide by 2 and just get rid of it?
Yeah.
Is when we divide by 2 here and here, these guys cancel out and it'll just become 0 on the other side. Okay, so far so good. But I don't know, I'm a little worried about how we're going to separate these unless we will have to bring in sine and cosine functions to simplify this.
I don't want to
You
do
won't be able to factor this, right? Because you have cosecant squared, but then we still have that cotangent and cosecant in the middle. So factoring is not going to work. So I think it might be easier to try and see if we can put these in sine and cosine forms and then see what it simplifies and looks like. So how can we rewrite cosecant squared of x?
1 over sine.
Alrighty, so he becomes 1 over, that would be sine squared, right, for that first term?
Mm-hmm.
Okay, and then what do we have in the middle term for the cotangent?
Or cosine over sine.
Alrighty, cosine of x over sine of x, and then of course cosecant would again be 1 over sine. And then we still have minus 1. So if you clean this up, what will you get?
Oh, crap. 1 plus cosine over sine squared x.
Oh yeah.
Yeah.
Or saying 1 plus cosine of x, and is the whole thing with the denominator?
Like, I think
Yeah.
it's, yeah, just, yeah, the 1
Okay.
plus cosine x.
And then you still have that minus 1 at the end. Yeah, because these guys here will also multiply to become sine square, right? So since you would have the same denominator, you can go ahead and combine this side with this side, which gave you the 1 plus cosine of x. But since this last -1 did not have a denominator, you cannot include that in there. So what can you do if you wanted to bring him to the party?
Make a tangent.
Can we find a common denominator?
Multiply by sine squared.
So what are you
Just
thinking?
1 over sine squared. Would it just be so 1, okay, yeah.
Okay, go ahead.
Never mind, I think I'm wrong.
What were you thinking? At least tell me that.
I was gonna try to turn it into tangent and then do the or like the tangent. I was gonna make it more complicated than it had to be.
Yeah, because of that sine square, I'm not sure how that would work. What I would suggest is just multiplying this side by sine square of x. So you can get a common denominator.
So then it's 1 plus cosine minus sine squared of x over sine squared of x.
Yeah.
You can see. Now here.
Okay. Any ideas where you want to go next from here? Because we're close to the end at this point.
No, they don't cancel yet.
The sine squared x wouldn't cancel out, would they?
No, because since we actually brought it up with our, by multiplying this -1 with sine squared, now that it has become part of the numerator, you just cannot cancel them out individually. But what you can do is just multiply both sides by sine squared of x, which is our denominator here, and they will cancel out, leaving us with 1 plus cosine of x minus sine squared of x equals 0. Actually, you know what? I think we went the wrong way, and I'll tell you why. Because
We're stuck.
we're not stuck. We're actually having to do a bunch of extra steps right here, because when I actually solved this earlier, I converted the cosecant into cotangent, and it didn't have quite as many steps. But now that I'm seeing that when we converted it into cosecant and kept the cosecant, it is a longer process. But like I said, we are close to the end. At this point, you actually want to use your trig identity here and rewrite this guy into cosine so that our entire function is going to be as a cosine function. So you will end up getting 1 plus cosine of x minus, and then what do I put in here?
1 minus cosine x.
1 minus cosine squared, yeah, very good. And then distribute that negative sign. So we end up, well, this guy will be 1 plus cosine x. This becomes negative 1. Negative and negative makes that positive. And we do have a light at the end of the tunnel. Just hang in there.
I see the light.
So the ones cancel out. And you know what? It's actually the stinking one which is giving us all this trouble. If we could have canceled him out earlier, we would not have had to go through like 50 different steps. But that's okay. We, play along and we learn how to go about doing this. Okay, now what are you going to do?
Just pull out the cosine.
There we go. Bring it out.
Oh my god.
I know.
I thought the one was a 2.
Okay, like I said, there is a light at the end of the tunnel, which will be you take your cosine of x, set it equal to 0, and 1 plus cosine of x, which of course this guy, when you move the 1 to the other side, becomes negative 1. So what kind of x values are we looking at for this guy?
Pi over 2, 3 pi over 2.
Very good. And for this side?
Pi.
Oh my gosh, we still have to check. The problem that never ends.
But here's the thing, guys. You are not done after you find those. Remember how we squared both sides to begin with? So remember, this is the extraneous.
Oh no.
Sorry. So we have to now check for our extraneous roots.
God, we still have to check.
Oh, I cannot wait for this pen to start working. This is horrible.
Especially the problem right before that. It's lasting forever.
I know. Remember our original problem, if we can find it, was cosecant of x plus cotangent of x equals 1.
Cosecant of pi plus cotangent of pi is 1.
So what is cosecant of pi halves? Because cosecant would be 1 over sine, right? And so sine function is 1 at pi half, so cosecant would basically be 1 over 1, which would come out to be 1. And cotangent would be cosine over sine. So what will cotangent of pi halves come out to be?
0?
0, yeah. So you end up with 1 plus 0 equals 1, or basically 1 equals 1. So this guy is good to go since we got a true statement. Then our next angle was 3 pi over 2. So same thing for 3 pi over 2.
So it's 0. Or no, is that 1?
For cosecant?
Or is that -1 for cosecant?
I believe so, because your sine is -1, right? So you would have -1, 1 over -1, which would become basically -1. And cotangent will be what?
3 pi 0?
Will be 0. So in this case, since you're getting -1 equals 1, we know that's not true. So it looks like he is our extraneous solution. So 3 pi over 2 will not work. And then the other angle we had was pi.
Yeah.
So for pi,
So that's 0 then.
for cosecant,
Yeah.
you sure?
No.
Think about it. Cosecant is 1 over sine. And
So
sine,
that's 1 over 1 then, yeah? Or -1 over 1?
I think you're confusing your points.
Yeah, hang on.
Okay,
-1
cosecant
0.
is 1 over sine. And what is sine at pi?
0.
So what is 1 over 0?
0.
Oh,
No. Undefined.
undefined. Thank you. So this guy here is undefined.
So he doesn't.
So honestly, that should tell you this is not going to work. Cotangent of pi comes out to be what?
Okay.
Because that is also 1 cosine over sine, right? And if
Yeah.
sine is 0, which means this guy is also coming out to be technically -1 over 0, which is also undefined.
An undefined answer plus an undefined answer equaling 1.
So basically, you're not going to get any answer, which means this guy basically is not working out either. So that first undefined, we knew this was not going to work out no matter what. Looks like the only answer that worked out for us is this first one that we looked at. After all that, you got one answer.
I guess one answer is better than no answer.
That is very true. I do agree. So this here, guys, is going to be our answer. And again, they want us to do this in the interval of 0 to 2 pi. So we're, of course, not going any further than that. You don't have to do the plus 2n pi or any of that.
We did it.
Oh, this took us a lot longer than I was hoping. I thought we would have time to talk about the exam, but I guess we're not. So, yeah, this turned out to be an interesting problem that we did here. But, you know, and this is kind of what I was mentioning, because when I did it, and it's right here at the top, when I made my substitution, instead of keeping the cosecant function here, this is actually where I converted this guy into cotangent, and I had quite a few less steps than what we went through. But you can see, just depending on what substitution, what identity you use, and how you go about, it can end up giving you a drastically different problem, right? Because this one just ended up being quite a bit more involved than I thought it would be. So any questions any of you had on this example?
No. Is there like a easier way to determine like which like factor to convert it into, or is it just like guessing and hoping that it works?
I think it really just comes down to guessing, and maybe with practice you can see if something seems easier. But you know, since I thought I had done cotangent and it worked out, I didn't think turning it into cosecant would be such a huge problem. But as I had kind of mentioned, what happened when I did my example here, when you actually turn this into cotangent instead of cosecant, the 1 canceled out. So you see how we have this -2 left behind here? I did not have this because my positive one and negative one actually canceled them out at this step right here, the one above this. So I actually did not have anything left over like this -2, and I was able to factor my cotangent and go from there. But since we had this -2 left behind here, that's actually the main reason why we had so many extra steps, because we had to find a way to get rid of that -2. And you can see that did not happen till we basically, what was it, got down here.
Yeah, to the very end.
Where we canceled out our 1 and -1. So yeah, because of that stinking little 2, this took us a little bit longer. But like I said, it at least gives us an idea of what happens when you go one way instead of the other. But honestly, I don't know if there's a shortcut or an easier way to see which calculation will lead you in which direction, unfortunately.
Dang.
I know, sorry. Jose, I haven't heard from you. Are you okay? Did you have any questions?
Yeah, it was just a long problem.
Yes, sir, it definitely was. And me writing by hand doesn't help us out either. So what I'll do is I'll go ahead and obviously put all of this on our D2L shell. So I've got the video recording and also the coursework that we did. So what I would like us to do next time is I would actually still like to review your exam with you. So on Tuesday, maybe we'll start by reviewing the exam first. It'll take us maybe about 10 minutes or so. And then I still did want to talk about a couple more examples from this section because I just want to make sure you are comfortable using the quadratic formula to solve some of these examples. I'd like to do a couple more before we get into our next section, which would be 2.4. Okay?
Okay.
Okay.
All right, and then I still need to open up homework for 2.3 and 2.4, and I think 2.5 is the last section in here. So I'm actually going to do that as soon as we're done with class. So if you guys are still working on 2.1 and 2.2, make sure you continue working on that, and then this afternoon you'll have your other homework open. And since we are doing this all online, you know how in class I was giving you quizzes on each section? Instead of that, is it okay if I do a quiz for just the entire chapter? Or would you prefer each section?
Personally, I prefer each section just because it gives it, like, if I do really good on one, then I fail the next one. It's okay because it kind of balances itself out.
Okay.
So I like the more opportunities.
Okay. So Sydney and Jose, are you okay then? I can do individual sections then.
Yeah.
Yeah, that's fine.
Okay. All right. So I'll go ahead and do that. So I guess I'll open up your homework and start putting quizzes for each section of chapter 2 up on WebAssign.
Okay.
Are
We're only going to have one attempt on quizzes, right?
You know what? Again, since we're doing an online format, I'll make it as 2 attempts, just like your exam. So if you don't like the score you got the first time, you can take it one more time.
All right.
Okay, and I'll try to keep it to 5 questions like we were keeping it in class.
Okay.
Okay.
Okay?
All right.
All right. Do you guys have any other questions for me?
Are you gonna upload the 2.4 section after today, or are you gonna wait until after we finish up?
No, no, because that video took so long to render that I'm actually going to be recording today and tomorrow and try to put as many videos as I can. So I'm going to do this for all of my classes. So I'll probably put up your 2.4 and if I can 2.4 videos by tomorrow or at least Saturday.
Okay.
All right.
All right, very good. Any other questions, guys?
No.
No.
Jose?
No.
Okay. All right, guys, be careful, be safe, and I will see you guys on Tuesday. Have a great weekend.
Bye.
Bye.
Bye. See you.